because there is such thing as a parallel entry. Yeah, parallel. You ever heard of a parallel? Well, that's when your students don't recognize that they've got some awesome wind. They come in on a parallel, they turn, and the wind blows them over, and now they're on this side of the course. Well, if they make another left-hand turn, they're going to be clear out here. There's no way they're going to make it back. So at that point, you've got to be smart enough to teach them that these are the standard procedures unless you mess up. If you mess up, you need to save it. How do I save it? I look down at my course. My course is to my west, and I was going to turn east. Where am I going to turn?
West.
West, because that's where my course is. And that's why we say we're turning to intercept the course. Generally, we should be in the direction of, but if they screwed it up and wind pushed them over, it does happen quite regularly. So this is once again where we go back into our whole reverse sensing conversation. The course is to my west, so I should turn. So what are you doing making a left-hand turn? And that's where you've got to drill that into them during stage one, is that they are so used to looking at their course needle and saying, it's to my west, that when you're doing holds, it doesn't even phase them. They automatically look at their course, and they'll look at you and go, I'm supposed to turn left, but my course is over there. Good catch. Let's turn right instead then. Okay?
Parallel. What about the deer trout?
A deer trout? Whatever you want to use. Okay. So those are my whole entries. Alright, so why is a teardrop preferable over a parallel? Oh yeah, I'm on the protected side. The only time that I'd be choosing between the two is when I'm coming straight in on it, right?
Mm-hmm.
Well, parallel, you would already be dead on course, and then you're going to turn off course and try to get back on it in one loop. Or I could go out teardrop, and now I can come around and intercept it. Now notice that on the teardrop, the other thing about it is, on a parallel, from this point forward, you are getting closer and closer and closer to your fix. You're running out of time. On a teardrop entry, you technically could just go to a 90-degree intercept if you'd gotten blown off course, and you're not getting any closer until you intercept. So a teardrop will always give you more time to actually get back on course and find that course. Okay? It's the same thing now. Why is a teardrop preferable over a direct? Well, in that situation, I'd be coming in on this line. If I did a direct entry, I would turn. I would overshoot my course and come back around with a 45-degree intercept. Once again, from this point forward, I'm getting closer and closer to my fix, and I'm running out of time. If I did a teardrop, I'd come out here, and I'd have plenty of time to find my course. So the teardrop is always going to give you the most time to get back on course and fix anything that you may have screwed up. So that's why it's always preferable. The teardrop's always going to be preferable over the others. Parallel is always going to be preferable over direct. Direct is the least desirable. And the more that you guys do this with your students in the simulator, that's where I learned this, was doing it in the simulator with them and giving them different wind conditions. I realized that that direct just sucked. Every time they tried to do a direct entry and they had the choice between another one, they would mess it up, especially with wind. Questions? Okay. There's my hold entry procedures. We understand the magic number. Okay. The only time, now here's the next thing for knowing the magic number is always the same as my what heading? Outbound heading. That is applicable only when I'm told to hold as published. Okay? What will happen is people will get obsessed with that. Oh, it's my outbound heading. Well, that doesn't really have anything to do with determining anything unless you're on an outbound heading. What it is so that when I've got a hold that's published like this on a chart, it'll give me my outbound heading like that. So if they just say hold as published, I'm looking for that number with the arrow pointing away from the fix. That's my magic number. And so that's where you're trying to go. So when I'm looking at a map, boom. And that happens, especially that's going to happen, this is going to be more applicable to a procedure turn. I've got a hold in lieu of a procedure turn. What's my magic number? Look at the chart, it tells you right there. Because I didn't actually receive a holding instruction, so how am I supposed to apply it? Magic number, it's right there. Questions? Okay. Going fast, here we go. Timing in a hold. I'm flying this direction at 100 knots. I have a 20 knot headwind. What's my ground speed?
80.
Simple math here, 80 knots. All right, I turn my airplane around, 100 knots. Got a 20 knot tailwind. How fast am I going? 120. 120 minus 80? 40. The effects of wind are double. This is what you show them. This is how you teach them. That's simple. So in a hold, we're going this way, then we're going this way. So the effects of wind on our speed is double. It's not just a 20 knots that is affecting us. Okay? So I got a 40 knot difference in what's going on. That's going to be critical to how we explain timing. How does Jeppesen teach timing? Okay, so basically we should be 1 minute, 1 minute, 1 minute, right? The goal though is to get the inbound leg to be 1 minute. Inbound leg should be 1 minute. That's our goal. Okay? So what we do is we have to adjust the outbound leg to make that happen. So Jeppesen says that if I fly inbound for 1:30, what should I do?
Outbound 30.
Decrease my outbound by 30 seconds, right? Well, I've got a problem with that theory. We go inbound for 2 minutes and 20 seconds. What are we going to go outbound for?
Negative.
Negative 20. Is that going to work? Okay. It's awesome. We get these nice winds, especially over Fairfield. And this actually happened to me one day. I was teaching what Jeppesen said. And all of a sudden this happens one day and my student looks at me and goes, what am I supposed to do? I don't know. That's what Jeppesen said. So that's when I started thinking about it. I started drawing it out. And then we did it on the computer and stuff. The effects of wind are double. So how much am I over by?
20.
1:20. Or that would be 80 seconds, right? So here's the rule. If you're over, so I need to reduce my inbound time, right? I need to lessen it. I need to make it smaller. I need to make it 1 minute. So that's the key. If I need to make it smaller, I'm going to, that's the wrong symbol, divide it by 2 and subtract it from the outbound. When I divide a number, does it make it bigger or smaller? When I subtract a number, bigger or smaller? That's the memory aid, is I'm going to divide and subtract because I need to make it smaller. So I take my excess time of 80 seconds, divide it by 2,
40.
subtract it from the outbound, which was a minute. I'm going to go outbound for 20 seconds. I've got a rip-roaring wind if that's what's going on. But it's happened before. We were 2 minutes and 15 seconds is what happened to us. It was I want to say it was a 45 knot wind over Fairfield. Okay? So that's how I shrink it.
Sorry, can you do that one more time?
Yep.
I missed the end.
So let's do another one.
Windy.
So, inbound, 1:40. How much am I over by?
40.
Okay, I got to get rid of 40, right? That's the key.
Yeah.
I got to get rid of it. So I need to make it smaller, so I what? Divided by 2, if I can do the right symbol again.
It's 20.
20, and I
Subtract that from it.
subtract it from
60.
the outbound. The outbound leg originally should have been 60 seconds, right? Because originally what we do, once I've done my hold entry procedure, then I'm going to start my time, wings level or beam the fixed.